Saxon Algebra 2, lesson 76. Hope you're feeling fancy today because we have two fancy topics. Let's just be honest. They're just cute and special and they look hard, but they're not too bad. The first thing that we're going to do is up our skills with systems of equations. We're going to start, for the first time, solving three-part systems. They just have an x and a y, but they'll have three different equations that we'll use. And it'll require us to do substitution and elimination. It's kind of cool. So let's look at a problem. Example 76.1. We have three equations. I might have said there were only two variables. That's not true. There are three. Remember, this is how I make a z so that it doesn't look like a 2. I put a slash in it. And notice that when I'm writing out these equations, especially the ones that have three parts each, I organize it so that I can easily look down the columns and see the matching letters, all right? That will just help you as we continue to do these. I just always try to make that really clean and clear. All right, this is a system of equations. The first step, substitute whatever looks easy, okay? And what we can see in this system of equations is that that is all set up to go substitution-wise, right? X equals 2y, we can put it in here, and we can put it in here, and that's gonna clean things up considerably, isn't it? So I'm gonna have to slide my problem over a little bit, but we'll say 2y plus y, right? I substituted this in here and got that. And then I'll do, let's see, if this is A, B, and C, then this is the new B, and let's do the new C. Again, x equals 2y, so we put in here 2y minus 3y. Okay, so there's our substitution. And now we can, I'm gonna put this around it again. We can add these like terms, can't we? So we'll have 3y right, there's our new system. And now we're gonna have to figure out step 2, which is now eliminate, okay? Just by substituting in A into B and C and then adding like terms, we've created what looks now like a very normal kind of system of equations. So I look down the columns. I could multiply the bottom one, let's call them B and C still. I could multiply C times 3 and get these to cancel, or I could multiply B times 2 and get these to cancel. I would rather multiply by 2 than 3. So that's my plan. I'm gonna cancel the z's by multiplying this one by 2. So 2 times b is now 6y plus 2z equals minus 18. C stays exactly the same. I'll copy it over. This is positive 9. So that's positive 18. I know, so suddenly I turned that into a minus 9. I was trying to figure out why I did that. Just rogue copying. Okay, so that was my mistake. I just picked up a minus sign. So this should be positive 18. Now I am ready to combine. These cancel. We get 5y equals 10. John, thank you so much. So we get y equals 10. Now let's look at our equations and see what we can do to solve these. We can even do some of it in our heads, right? 2 times y equals x. Well, that means x is going to have to be, oh, wait a minute. Look what I did. Y does not equal 10. Y equals 2, right? 10 divided by 5. Now, let's do this. X is 2 times y, so x must be 4. And then z, they all add up to 9. 4 plus 2 is 6, so z must be 3. This is one way to show the answer. Preferable is to write it as an ordered pair, which I'll do down here. 4, 2, 3. Not an ordered pair, sorry, my bad. An ordered triple. If you gave me this box on a test or a review problem, I would ask you to reformat your answer. Okay? 4, 2, and 3. Beautiful. All right, so these problems aren't particularly difficult. They're just a little longer. Let's try one more. Use substitution and elimination as necessary to solve this system of equations. Copying them is always the first step. I heartily recommend you copy. And I'll put a little caveat on that in just a second. Notice how I'm making sure they line up into columns by letter. Now, the last one I'm going to copy as it is in the book. I know that my first step is to substitute whatever looks easy, and I can see that equation C is just begging to have the 3z added to the other side. So I'm going to rewrite it as x equals, and it'll become positive. If you see this in the book and you want to copy it as this because you realize you need to just clean it up in order to get ready to substitute it, that's fine. All right, now this one's going to be a little bit trickier because our other equations that we're substituting into have numeric coefficients. So we're going to have to multiply as we substitute, but that's not a big deal. So we're going to put 3z in here. I'm going to write it 2 times 3z and this will be 3 times 3z. I'm just copying all the rest as is. Now I've substituted C into A and B. So this is my new A and this is my new B. Now I need to multiply these out and then add like terms, right? Because I have 2 Z terms now. I'm going to do that in one step by making notes. This will become 6z, and then 6z minus z is 5z. The 2y stays the same. This is a positive 5z now, right? It's plus 6c minus z. That gives me 5. The 2y is unchanged, and the other side is unchanged. This becomes 9z, and I add it to 2z, so this is going to be 11z. It sounds like I'm saying 11 z's, doesn't it? Isn't that Pooh Bear that talks like that? I do believe. All right, and then my y term stays the same. Okay, beautiful. I like that. Here's my like terms that I was combining. Okay, so now we have a new b, or it's a and b this time. What do we want to do to make these guys manageable? Well, as I glance down the columns, I see, man, this one would be a lot of work. We'd have to multiply by 11 and 5, and one of them would have to be negative. Oh, I forgot the last part of this. But the first term, the y term, it's the first term now because eliminated our x's. Our y term is pretty straightforward. We can just multiply b by 2, right? And that will come out to minus 2y plus 22z equals 42. Okay, so this is 2 times b. What I'm going to do is gently squiggle this one out so that I can add these two together without rewriting the whole thing. This and this cancel. This becomes 27z, that's a big number, equals 54. Those are big creepy numbers, but I quickly realize 27 times 2 equals z. So I know that z equals 2. Now I can plug back in x equals 3 times z, so x must equal 6. And then y, is there an easy way to do this one? No, I'm gonna have to plug it into one of the equations. So I'm gonna go up here to a, and I'll say 2 times 6, because we figured out that x is 6, plus 2y minus z is 2 equals 12. So this is 12 minus, this is 12. I combine it with this to get 2y plus 10 equals 12. I subtract 10 from both sides and I get 2y equals 2. Right? I did that in my head because I'm running out of space really quickly, right? So 2y divided equals 2, divide both sides by 2, y equals 1. Okay? So we can plug into any of these equations that we want. Final answer I'll write as an ordered triple right here. 6, 1, 2. You always want to make sure your variables are in alphabetical order. Yay, that's the right answer. Okay, so these problems, they're fancy, right? They're not all that difficult. It's just substitution and elimination, which we've been doing for quite a while, but it's fancy. Okay, now we're going to change topics, right? We're going to be fancy in a new direction. And this time we're going to turn our heads to trig. Did I just hear you groan? I might have. All right, we have dealt with a situation where we have a negative direction. Remember, this is the direction. And this number is the distance. Whoops, not distances, distance. We can think of them as angle and hypotenuse too. That's not wrong, but right now it's helpful if we think about them as direction and distance. Now we figured out that we can do this negative direction, this negative angle thing. Instead of going up 20 degrees, we go down 20 degrees, right? That's probably a little bit bigger than it should be, but I want you to be able to see it. That's 20 degrees, right? And then we say this is 4. Now, we're going to curveball it one more time, because what I'm going to do is I'm going to say, what if we put, I'm going to draw it on top of this. I'm thinking about how I want to do this. What if we want to make it a negative distance as well? What happens is we measure down the 20 degrees, right, just like before, but instead of drawing the line this way, we make it go this way. We go backwards. Okay, so a negative distance I always think of it as a car. It goes in reverse from the axis, or the origin rather. Okay, so what we do when we're dealing with negative vectors is we measure the angle, just like always. I did this. But then, instead of drawing my line this way, I put it in reverse and went this way. Now we have to draw the new triangle here. And what's very important is keep track of the size of your angles. If this is 20 degrees, then this must also be 20 degrees. And then we could calculate this distance. Let's see, that would be 160, right? Because it's not the full 180, it's 20 degrees short. So this would be 160 degrees. So things go a little nutty when we start throwing negative distances in. Just think of it though, you measure the angle and then you go backwards. You put your car in reverse and back up the same number of units as whatever it says. All right, so now we've already drawn this picture, so let's just go right into the problem. 76.3, John wants us to add -4 at -20 degrees plus 5 at 135 degrees. Okay, so what we're gonna be doing is we're gonna be making right and up coordinates, right? For both of these triangles. The short line, these are like fill in the blanks, right? Here, let me move up a little. These are fill in the blanks. This will be the positive or negative sign. This will be the value that I'll find by using cosine and sine. And let's see, to get the right value, that'll be the adjacent side, so that will be cosine. This will be sine. Always we can do it that way, right? We use cosine to find these. And we use sine to find these. Then we will add them together to find our new answer. That's gonna be really crowded. I don't like that at all. But that's what we'll do. Okay, so we've already drawn the triangle for -4 at -20 degrees. We went down 20 degrees, but instead of drawing the +4 for the distance, we put the car in reverse and we backed it up this way. So this is the triangle that we'll use right here. So to find our right value, we will multiply the hypotenuse 4 times the cosine of 20 degrees. And to find our up value, we'll use sine. 4 times the sine of 20 degrees. We'll get those values. I'll give them to you in just a second, but we'll have to think about the sign. The right value is going to be negative. The up value will be positive, right? I can just logic those out. I can tell you that this number equals 3.76. I'll write it there, and then I put it right in here. And then our up value for this triangle is 1.37. Use the calculator to get those. Remember, we enter the degrees, then hit the function button, cosine, then multiply by 4. Round it to 2 decimal places. Good, right? We've been doing that for a while. I hope that has become, second nature might be kind of an extreme way to say it, but I hope that's become kind of comfortable. Now let's draw our second triangle. I don't have enough space here, so let me go over here. 5 at 135 degrees. Okay, so this one's old school. There's no negative signs in there whatsoever. We have no drama. So I like to figure out which quadrant it's going to be in so that I can zero in my diagram on that quadrant. When we have the negatives, it really can be a little mind-blowing to try and figure out ahead of time which quadrant you'll be in, but because you're backing up the car, that's crazy. But This one's easy. I know it's going to be in the second quadrant. I have to go 90, and then I have to get 45 more. Right? This much is 135. It's 90 plus 45, and that leaves me with 45 degrees here. That's one of my, that's our 45, 45, 90 triangle. We could calculate these by hand, but we can use the calculator on this problem. But as soon as we see one of those familiar old friends, we know, oh, these numbers are gonna be kind of cool. We also know that cosine and sine will be the same. When we use this triangle that has the equal measures, that means sine and cosine will be the same. And I just got done explaining to the advanced mathematics students why that is so. You'll learn next year. Okay, so our distance is 5. So to find the right value, it'll be 5 times the cosine of 45 degrees, and to find the up value, it'll be 5 times the sine of 45 degrees. You don't have to recopy, but I'm gonna recopy my box because I want to have the answers all at the end here. Okay, and I also don't like how squished I was before. Okay, so before we had, let's see, it was a negative right, 3.76, and it was a positive up of 1.37. Okay, now we're doing the second triangle. We see that our right value is again going to be negative and our up value is again going to be positive. Run these through the calculator and we get 3.54 for both. So I can copy that here. And now we're ready to add them. And we will get let's see, I can just do, because these are going together, they're super easy to add. 0, 3, 7. So it'll be negative 7.30 to the right. And then these are gonna be ups, 194. They're the ups. This is our final answer. Yay! Okay. This triangle was old and familiar. This one had a negative direction as well as a negative angle. I'll tell you how I feel. Negative angles don't bother me at all. It's very easy to just measure down this way. Negative directions drive me a little crazy because I always drive the car this way and then go, wait, it's a minus sign. So I have to go back to the starting place and throw her in reverse, all right? It's a little bit more of a pain. It's a little bit more mind-blowing. You have to be careful about these angles. Watch for vertical angles as you redraw the triangle after backing up the car to make sure that they're correct. Sometimes it's, not sometimes, I would say almost always, our pictures aren't precise enough that makes it easy. We have to think about how do these angles flow from one to the other and look for verticals. And that will help you. Guess what? That's all. Our fancy lesson is done. I hope you enjoyed it half as much as I did because I thought that was really fun. Okay, thanks, bye.